If you're given certain information, you can make these proportions out of it. For example, if you have a triangle, and in that triangle you have a segment that's parallel to the base, that segment creates a proportion. If you label those parts out, you need a pencil or something. Write something down. Come on. It creates a fraction. So what I want you guys to do when you see something like this where you have two parts that are parallel within a triangle, turn it sideways. If you turn this sideways, pardon me, if you turn it sideways, what was this, A, B, or did I have A here? I had A, B, and then C and D, or whatever. Doesn't that just create a fraction?
Yes.
That's all it is. This is creating its own fraction. This side is to this side, as this is to this. It makes a fraction. And you can set up and solve, cross multiply and solve. Okay. So when you have these triangles, anytime you have a triangle, and you have this extra segment that's parallel to the bottom, these two create a fraction, these two create a fraction. That is the most simplistic way that I can think of writing it out for you, as opposed to getting into the whole long-winded definition, because the definition is boring and stupid and you're never going to use it. But if you look at a diagram that you've got and you notice you've got two parts parallel, if you extend that secondary parallel part, hey, look at that. Fraction, fraction. Very visual, okay? It's the idea of just looking at it. So, there's one of them. Fraction equals fraction. You okay on that one? Bless you. Another one. Actually, we'll show you an example real quick. Oops. Notice you are missing a side length within that triangle. Notice you have a part that's parallel, the QS is parallel to UT. Notice if I create this as a larger fraction bar, I'm missing this, aren't I? So I get x over the 9. X over 9, 4 over 6. X equals 6. Go to the next problem. That's all it is. It's a matter of looking at that going, oh, all I gotta do is extend that secondary parallel part, make a fraction. It's a very, very, very fast way of doing it. Okay? Sir?
Can we do this for all triangles that we're trying to find?
If it's a parallel part, yes. Because what's happening is that by this being parallel, you've got all that, and you could write out the full statement. It's just a shortcut way of doing it. Here's another one. Oops. Screwed this up. No. No.
Not those, but the next one.
Why did this? There we go. So in the past, we've done this where we've had parallel lines cut by a transversal. Well, sometimes you might have more than one parallel line. You might have 3 of them. You might have 2 transversals. So there's a whole lot of stuff going on here. Okay? Now, if you look at it, you have 4 segments that are on the inside. here, well, we write them out, oops. I'm gonna label this as X, Y, oh, probably should do a W. W, X, Y, and Z. Be okay with those 4 segments that are created? Tilt your head sideways. Hey, doesn't that look like a fraction? X over W, Y over Z? If you tilt it the other way, it would be W over X, Z over Y. Yeah, that's all it is. When you have 3 lines that are parallel cut by 2 transversals, tilt your head sideways, it'll look like this then. If these lines, well, that's not really parallel, is it?
Can you just have me take?
I could have, but that would have been too easy. If I have 3 lines that are parallel, turn your head sideways on this, and then you, like I did earlier, W, X, Y, and Z. Hey, look at this line in the middle. This middle one looks like a whole lot like a fraction bar. Segment over segment, segment over segment. That's it. Okay?
If there wasn't that straight line.
Then it won't work, because then you won't have 4 segments. Okay? Then it wouldn't work without having 4 segments. So what this would look like, what was that example? Is if I do this. In this case here, that's showing that you have 3 lines that are perpendicular to the same line. When you have 3 lines that are perpendicular to the same line, that means those 3 lines have to be what? Parallel. Very good. So knowing that I have 3 lines that are perpendicular to the same line, 3 lines that are parallel to each other, haven't I created 1, 2, 3, 4? Haven't I created 4 segments? Write them as a fraction. Right, tilt your head, and which way do you want to tilt your head? To the right or to the left? Does it matter? Yeah, if you do it that way, go 15 over 18 is 16 over X. Cross multiply and solve. These are really, really, really quick when you start to write them out like that. It's just a matter of picking out and remembering, hey, there's a couple of shortcuts that we can do. So, 3 parallel lines, 2 transversals. Again, think of this as a fraction bar, and they equal each other. It is the quickest way to show you guys that this stuff works. Once you get into the idea of which diagram, what are you looking at, it's very fast to set these things up, okay? And the last one you're gonna love. You will. Oh yeah, you wanna bet?
You know what math stands for? That's what we used to do.
I've never heard that one before. So let's say we have a triangle. Doesn't matter what the triangle looks like. Let's just say it's a regular old boring 3-sided triangle. Because, you know, if it didn't have 3 sides, it would be a triangle. So let's say this happens. Let's say you take one of the angles and you bisect it. If you bisect one of the angles within a triangle, it actually creates, excuse me, it creates not 2 congruent sides, it's going to create 2 similar triangles. It's going to create proportions that work. Here's what happens, and this is kind of crazy. If you take and you start where the angle bisector is, and you go out and around, and you go out and around, it's apart. So as I said, you're going to love this.
Man, you're terrible.
The two parts that it is, hey, oop. There's a fraction,
How's that?
Yeah.
and there's a
Look at
fraction.
that lovely heart was.
It's x over y, w over z.
Just go straight line.
Remember you said
That's
no
what
on-
creates a fraction. This is the proportionality of it. X over y is w over z. What you're looking at here is, as you draw out and around, you're circling the parts that are going to be the fraction. The first one you hit after you go through the bisector is the numerator. The second one is the denominator. Same deal on the other side. Numerator, denominator. It is a it is a horribly dumb way to do this, but it is so,
Guys.
come on. It is horribly dumb to do it this way, but it is just so visual, so easy to show by circling what you're working with. Same deal here. I could go through all these long-winded definitions all day long and show you guys how they all come up with it and how they all work, or show you a shortcut. Hey, this creates a fraction bar. Hey, this creates a fraction bar. Hey, this is circling what creates the fractions. It's more user-friendly this way. Okay? So these are other ways we can write out proportionality statements and get really boring with this. Or if you see a diagram that has one of these traits, why not have a shortcut? So what happens then is that you get stuff like this. Oops. This was the bisector, excuse me, it didn't. So in this case here, you are told that angle A has been bisected by segment AD, or AD is the angle bisector of A, however you want to write it. Okay. Psst, heads. Thank you, sir. You want paper? I got paper. Get a pencil. Alright. So if you do the really kind of silly way of thinking about it again, about showing it some love. I know it's not Valentine's Day, but out and around, out and around.
The sad thing about this is I'm forever alone.
So you have 4 over something is 4 over 4 root 2.
I know. You know what
Guys. What's the answer?
I'm forever
It's
alone.
4 root 2. It has to be.
Like, cause like the, we go over like a street
About what?
sign for, like that.
What about it?
We go over like a street.
No. It's just a number.
So it'd just be 4 over 4 root 2.
Yeah. Because these are the same. They have to be the same. You can do long-winded and go through it. 4x is 16 root 2 divided by 4, and you get x is 4 root 2. It works. It is special practice. Okay. Let me show you some examples.
That's the national championship. That's the national championship.
Guys, come on. Okay?
You always make sure the heart, like, on the point thing.
Yeah. You always start your heart at the angle bisector.
No matter what.
And that's how that would work, yeah.
Wow, I never thought a horse had a line working for me.
Okay. So, which of the 3 shortcut ones will this one match up to be?
The heart.
It's going to be the heart, because you have an angle bisector. So, start your heart at the angle bisector, come out and around, come out and around.
That's when X equals to 8.
I don't know what it is.
No, it's
8 over 12 is x over 9.
So that's 5, 6,
Cross multiply out.
6.
There you go. It's a matter of picking which of the diagrams does it look like. Once you figure out which one it looks like, it's super fast.
So is it okay if I did 9 over x equals 12 over 8?
Sure. But if you keep in mind that you remember you're going out
Up
and
down.
around,
Okay.
that means you're taking the ones on the outside, or the ones in front of it are always the top.
So you start with the,
Opposite.
well, what is that in the heart? Because it's the ventricle down here, it's the atrium, right?
Because the
Right.
atrium, because it's like in
Right,
the,
it's
in the
like
hotel, they
up
have the atrium.
Yeah, there's, that is true. Atrium, ventricle, go atrium. That's the part of the heart.
No, why not? No, you wanna know why?
Right? Everyone knows that makes that part of the heart, right?
I didn't know that. It was so bad.
But you remember it.
Here, guys, come on. Same deal. We look at the diagram here, and we try to figure out which of the 3 are we going to use to make this work. Which of the 3 of these are you going to use to make them work? Well, the middle one, right? Because you've got the 3 parallel lines. That middle parallel line acts like a what? It acts like a fraction bar. So now it's just a matter of which of these numbers you have to put on top and bottom, depends on how you see it. So if I look at it and kind of just tilt it this way, just by turning my paper, can I do it x over 10 is 6 over 8?
Yes.
Or could I have done 10 over x is 8 over 6?
Yes.
As long as you're consistent with what direction you're going, you're fine. So x over 10, 6 over 8. Cross multiply. 8x is 60. So it'll be 30 over 4. What do we get here? 7.5?
Yeah.
There you go. Okay. It's a matter of picking the diagram that's going to work the best for you. Once you pick it, you go.
So what does the book say about this? Is it like about true?
Oh, it's horrible. It's horrible. Oh, yeah.
Nasty.
There's once we get to this point, because this is the last section in the chapter, it's so much easier just to go ahead and say, hey, why go through the whole? If a line parallel to one side of a triangle intersects the two sides, it's not a half day, people. Wait, wasn't last Thursday a half day?
Yeah.
No, it was
Yeah.
Yeah, it was.
Yeah, it's dead.
Oh no! Wait a second. You'll hear Bianca Lana. Excuse me. The can I have your attention? The bells will be fixed.
He's at the door.
So, like I said, if a line parallel to one side of a triangle intersects the two sides and divides its two sides proportionally, it's not terrible, but why not just say, hey, if you've got two parallel lines, that one creates a fraction bar.
Yeah, why don't they use English?
They did. They just make it. A lot of times with these things, they're just kind of. They make things a little more. Guys. Now there are going to be. Who was it? We'll go this one. You get this one.
Oh, look at those little guys.
Is that Toby and Tony?
You're dumb.
We have a couple of files from this stuff, right?
What is it? Somebody in my
I'm gonna name my kid Brad. I'm not letting go of
I remember there was one that I had in
Don't let them go on that.
look for. And we're getting X minus one where you had to subtract out. I think it's a book problem.
He hasn't said anything. Maybe it's-
You're the, in 13, you got 2 X's.
Yeah, I know which one I'm thinking of. I'll show them that tomorrow when we do the review stuff. Hey, real quick, I want to show you what happens when you have.
Don't we do the hard to do that?
Oh my god.
Hey, ladies and gentlemen, you're probably going to want to write this one down. Because obviously this stuff that we've looked at hasn't been overly complex. But sometimes you're going to have to do multiple steps within one of these types of problems. And you're right. I think somebody already mentioned that this is one of those heart problems, because you'll notice that you've got angle bisectors. What do you mean? They're not necessarily the same. What's going to happen is that we're going to do proportions multiple times. Okay, we're going to kind of build ourselves out of from the beginning. That's kind of what you do. Excuse me. So, is everybody okay with me saying that there are 3 triangles that are created by that angle bisector?
Yeah.
So, what we're going to do is we'll go ahead and try and see if we can figure out ways to solve for each part as we go, as we get larger and larger. Okay. Now, excuse me. If we start here, out and around, out and around. D over 6 is 3 over 9. Okay. That was pretty quick. What do you get for D? You should probably be able to figure it out in your head. 1/3, so it's got to be 2. You okay with that?
Yeah.
Don't worry.
I should just got up and done this.
Now I'm going to erase this out so we have a little bit more space. Put a 2 here. Now I go again. Now, knowing that you have angle bisectors, knowing that you have that shared sides, this is the part now, obviously we wind up with, if I go out, I have B over 12. Then I have 6 over 9 plus A.
Wait, 12.
Yeah. So yeah, 6, right?
Yeah.
Oh, okay.
Okay.
I see.
So you have to start to play around a little bit of trying to figure out what else do you know. And I remember the directions that I think was parallel and there off the top of my head. Let me double check that real fast before I forget. I thought there was a diagram. Yeah, I don't remember if it did or not. No, now, in this case here, there, excuse me, in order for this, we know that we have, I can't say that these guys wind up being parallel. And it is the similar triangles, and you can use the ratios to go, but do. It's 1 to 3. So we know that in order for it to work itself out, A has to wind up to make this work. It's 1 to 3 for your scale factor.
So if you had to go like B times.
Okay. You know that your scale factor is going to be 1 to 3.
Yeah.
Because that's what it was. Okay. Now, what happens then? You can use that scale factor, and if you do so, if I do that here, what do I get for B? 4. Good. So I get B is 4. Now, if I do a 1 to 3 here, you're going to get 3 times 6 is how much? 18. 9 plus A times 1 is 9 plus A. So what's A? 9. So what happens here, what happens in this case is that you do use your scale factor when you get into parts of this. This is like the goofiest as this stuff can get, aside from having to take a section and subtract it out. Yes, sir? It doesn't necessarily always work that way. In our instance, in this case, it does. Okay? There are times that it works, sometimes it doesn't. Because now if you go to the next part, knowing now that this is 9, if I do my next part, here, going out and around, out and around, I have 5 over 12 plus C has to equal 7.5 over 18, 22 and a half. So you do your cross multiply again, but does that mean that C is going to have to be 4.5? Well, we'll see what happens. Okay. So what you're doing here is you're kind of building off everything. Yes, ma'am? Oh, C. C3, whatever. It's close. So when you cross multiply all that out, let's see. I don't know what 22 to 5 is. What? Doing a bunch of math, what do you get for C?
Even more green.
Huh?
It's 3. Yeah.
Well, you're getting lucky.
Can you reduce that fraction first?
Sure, if you want. Well, he's looking at this. 9, 9. It goes 9, 9, 4 and a half.
Oh,
So 3, 3. I'm sorry, 6, 6. Yeah, it's one. It's a 2/3, 1/3. Yes. So you get 3. Now, and that's great. You pick up on the number sense on it. That's fine. I have no problem with that at all. Okay. What we're showing is that you can still use all the different properties to make it work. And that's what you get into some of these things. You get a little bit of a big picture, big problem style. There is one other version of the heart problem that I'll show you guys tomorrow, but I'm not going to bother with that one today. 3.
Yeah, if you reduce that fraction, you guys, 7.5 over 22.5, you get 1/3. And then as you cross multiply, you're gonna get 12 plus C equals 15.
Yeah.
C equals 3. Much
So you can,
easier.
and you can continually use that 1/3 ratio too, and it works as well. Let's do these. Yeah. Let's do those.
Then it'd be like A, B, C, D, E.
That's not a lot of homework. When I get home, do this homework. And then Xbox until 12 o'clock at night, maybe even 1.
That's it, that's the last round.
Come back to school tomorrow. snows the hell out of here. Hopefully we have school Monday and Tuesday.
I couldn't
So
remember
we'll get this bitch done
Yeah, I couldn't remember
by June on time. We want to be here actually. So I hope I hope we don't have school snow days.
Yeah.
Because last year we didn't have snow days, did we?
Yeah, no, we didn't. Yeah.
I was good last year. Today's the 15th or 16th.
Today is